Welcome everyone to this webinar on natural materials, Volume 1. We'll be talking today about agri-crops in building industry. And I'm delighted to have here today three inspiring speakers, Cypren, Patrick and Elliot. If you don't know me, I'm Magdalena. I'm a knowledge exchange coordinator for CIAT Scotland East. And because we've got quite a lot of ground to cover, without further ado, I'll hand over to Cypren for the first presentation.
Thank you, Magdalena, and thank you to CIAT Scotland East for the invitation. Hello to Patrick and Elliot and to everyone on the call. A bit about me. My name is Cypren Edmunds, just so you know the surname. And I am the chairperson for Strawbale UK, which is the Association for Strawbale Builders. We have teachers and advocates, as well as builders, and the president for the European Strawbuilding Association. So, without further ado, I'm going to start off about me. My background. Why did I get into straw building? Essentially because I live in a 11-story conventional built tower building built from the 1950s, and I went through, like many people in those type of builds, went through damp and condensation. It was through watching an episode of Grand Designs that I saw Barbara Jones, and she was talking about the benefits of building with straw. It was new to me, very new to me, even though I had a background of construction. My family were a family of builders, but I knew next to nothing. In fact, I knew nothing about bio-based materials. So essentially what happened from there was that I went on to do a carpentry and joinery course, and at the end of that course we were invited to go to EcoBuild, an event that is now known as Future Build, and lo and behold, who should be standing in a corner demonstrating how to build with straw but Barbara Jones. She told me Jeffrey Hart was gathering a group of like-minded individuals to set up Strawbale UK, and the rest, as they say, is history. I became a founder member and I'm now the chairperson. So let's go on to the next slide, please. Thank you, Magdalena. So there are several methods of which you could build with straw, and just for clarification, I'm referring to straw as insulation, not with thatch for your roofs, okay? It's commonly known as the Nebraska method, and this is because the Americans started off building with straw back in the early 19th century, temporary buildings, and from there it became popularized much later throughout the years. Let's go on to the next slide, because this is going to be more illustrative, please. So the Nebraska method is also known as the load-bearing method, okay? There are several types of ways in which you could build with straw. There's the load-bearing, there's the lightweight timber, there's the infill or framework, so the timber carries the load, or there's the hybrid, which straw bales and timber also carry the load, or, as I'll go on to talk to you a little bit later, the prefab method. Let's go on to the next slide. Thank you very much. Right, so people often ask, how old is this method of construction and do they stand? So I'm going to really throw out the Three Little Pigs story right here and now, because as you can see, this building in Nebraska dates from 1914, and the whole principle about working with straw is that it does last. Yes, it's long-standing, it's incredibly robust, and for those of you who are on this call for the first time and who may not have ever heard of working with straw, yes, it does work. Can we go on to the next slide, please? So that particular example I showed you back then was the site that was in America. Over here in in Europe, I was going to say in the UK, but in Europe, we have the oldest straw building, which is in Montargis in France. It's over 100 years old, still standing. I myself have visited it as part of the Upstraw project. The Upstraw project was an Interreg funded project from 2017. Northwest Europe associations got together to decide to really broaden the awareness of straw, specifically to the public sector. But one of these sites that we visited was this particular one, and it's still standing. It's a load-bearing site and absolutely fabulous. Can we go to the next slide, please? So, as I said to you just a moment ago, in my particular case, the reason why I got into straws because that picture, it isn't mine, but that particular picture on this slide was very evident in my property. No matter how much I tried to get rid of the black mold, it just wouldn't work. And the reason why it wouldn't work is because of the materials. So conventional materials that we work with, for those of you who don't know, concrete, steel, and plastic really do not enable for moisture to flow through the air in the way that natural materials do. The fabric of natural building materials manage to they manage moisture through its ability to absorb natural fibers. Specifically, let's say they absorb lime plaster and they desorb, and because of that, it means the vapor is an open structure, and these natural materials are commonly called breathable. Next slide, please. So I've put here that straw reconnect agriculture industry and end users. And what does that mean? So that particular slide, this particular picture, hones in on those built up areas, but you can also see the green fields around it, okay? It's a co-product, straw is a co-product of grain crops and can be renewed and regrown on an annual basis, and it sequesters biogenic photosynthetic carbon dioxide in its growth cycle. So it's good. It's very, very good, unlike plastic that we use in conventional materials today. So can we go to the next slide, please? It also has low embodied energy and low emissions in processing from the field to the building. Due to its excellent thermal properties, it vastly reduces the need for heating, thereby greatly reducing carbon in use. So it also is easy to disassemble for reuse, and many of the constituent parts of straw buildings are biodegradable. So whatever we build a straw building with, we can put it back into the earth, essentially, unlike concrete and steel and plastic. Can we go on to the next slide, please? So how do we scale? How do we scale straw buildings? Essentially, what we need to do, because we're still in our infancy, is to have a conversation, an adult conversation with the other parts of the construction industry. And this specifically means talking to farmers. At the moment, we're talking to the National Farmers Union and to the other actors of the finance industry. There are a small number of financial institutions that enable people who want to build with straw. They're more empathetic. They understand that we need to be working in a more environmentally friendly way. And ecology happens to be one of those organizations. This particular map is of some of the homes that have been built with bio-based materials. But if you were to go over to and you can't see it, but if you were to go over to the Channel, to France in particular, you would see that that map is practically all green. And specifically because the French have a different way of working with their building regulations than we do. They're about 20 to 30 years ahead of the game Our regulations, if you like, inhibit us from doing such things, and we need to change that if we're going to build in an ethically sound way. Next slide, please. Where to now? So the industry, the bio-based industry, specifically the straw industry, in some aspects of Europe in particular, have really grown and shot straight through the roof. This particular slide illustrates the company EcoCom, who are manufacturers of straw panels. They are presently building a very, very big factory. And as you can see, they're using automated production robots. Yes, this is the way forward, or it is a way forward for us to really work with AI, for example, to adjust and to get the environment, as in the sector, to understand we can go with this and we can build quicker and faster and more sensibly. Next slide, please. And as you can see in this particular slide, there are two examples of the innovative way that organizations like EcoCom on the left-hand side of that slide, and on the right-hand side is an award-winning house from a company called Modulina. They're from Lithuania, and it really is the way to move forward. It's very simple. You could put a house together in a matter of days, and if you're a carpenter, it's a piece of cake to you. Can we go to the next and last slide, please? So that's it. That's me. A bit about Strawbale UK. We are very open to members. Anyone can join. You don't need to be a builder. You just have to be an advocate should you want to build in a more sensible environmentally friendly way. Save the date, because on the 12th of September, we will be hosting our first in-person event for many a year. This will be in the University of Wales, Trinity St David's, and our theme is around biophilia. So please put that date in your diary, look on our website, and you will see more details regarding that. And the technical guide, which I've put down on the furthest right side of the slide, is a free product for you to download. So go to our homepage, you can download it there, and everything that I've spoken about in this presentation, you can scour till your heart is content. That is me. Thank you, Magdalena.
Perfect. Thank you so much, Cypren. That's been very informative. Before we take any questions, I think we should move to our next speaker. So I would like to introduce to you Patrick. Patrick, would you be able to tell us a little bit about yourself, the project you're leading, and your background? Thank you.
Hi, my name is Patrick. I work as a lecturer researcher in Technological University of Dublin. My original background is actually architectural technology, and I was a member of the precursor to CIAT, the BIAT, in the olden days. I'm involved in research in a range of areas, but particularly circularity and bio-based materials. We've just completed a project called Drive Zero, where we looked at the application of modular prefabricated circular plug and play wall and roof components or whole assemblies to retrofit Irish housing. And we did a demonstration of that. And that has led to our involvement in this project called Circular Reno, which is about modular renovation using bio-based materials. And I'm leading one of the work packages within that project. So that's what I want to speak about today. Can I go ahead straight into it?
Absolutely, please do. Thank you.
Great. Okay, so the Circular Reno project, I'm going to focus on work package 1, which is the package I'm leading, which is about demonstrating bio-based solutions and developing supply chains. So an overview of the project It's a European Interreg project seeking to develop modular bio-based construction materials from agri-crops in particular. So it's not looking at bio-based resources from the forestry or wood sector. It's very focused on agricultural crops. And the concept is to connect farmers with social housing providers and public authorities in general to try and stimulate the development of local bio-based supply chains. So they're looking to set up 6 local supply chains, connecting farmers with industrial SME or even startups to develop particular facade and roof systems incorporating bio-based materials. They're going to be demonstrated within a range of housing association retrofit projects. So that will be a total of 4 projects with 88 homes. And from that, we hope to make aware and increase knowledge among social housing and public authority sector that they can utilize these solutions in retrofit and new build. So that's the concept. The Irish partnership partners are the social housing organisation TUA Housing and KORE Retrofit, who are a one-stop shop deep energy retrofit company. There's 3 work packages in the project. The first is about, work package 1 is about informing and guiding the sector to promote and facilitate supply chain development, and also to undertake demonstration and research into the materials. The second work package will be retrofitting 10 social homes using modularized solutions. And the third work package will be really a dissemination and training work package about the findings from the project. So just an overview, we're going to, here in Ireland, focus on straw, miscanthus and hemp. Because there are already some resources available, although not particularly very small in miscanthus and hemp. You know, we're basically wanting to engage stakeholders across Ireland, and in some cases we have people connecting from the UK to get involved in strategic planning for the sector. Out of that, we hope to actually help facilitate and possibly kickstart some supply chains. So we are in discussion with different grower groups and different industry partners who are interested in this. And the third key aspect is that we will design and demonstrate some pilot mock-up modularized panels for both new build and retrofit using these materials. And the context here is quite interesting in that we're seeing a farming sector in Ireland and in Europe in transition. There's an increasing policy drive to decarbonize the sector. So we're seeing that now being embedded in policy and legislation. And there's also growing interest in the potential for carbon trading in the farming sector, and bio-based construction materials may provide one avenue for long-term sequestering of carbon, which could become a trading benefit. So there's interest from the farming sector. And then we're also seeing significant changes across in the construction sector, not only with the continued drive to improve energy efficiency of new build, but particularly to decarbonize the existing stock. So there's a significant retrofit initiative happening, and that's in parallel with an increasing interest in moving from an operational energy and an operational carbon assessment into whole life cycle energy and whole life cycle carbon. So that's creating quite a bit of interest in low carbon and carbon sequestering building materials such as bio-based materials. So they're both very positive contextual factors. We've been researching the resource in Ireland, and we have a very significant straw resource from the tillage sector, although we're primarily beef and dairy in Ireland with some lamb. We do have a tillage sector. There's about a quarter of 260,000 hectares or thereabouts of straw available. We have a very niche and small miscanthus sector, but with interest from the farming community. And we've also an emerging hemp sector growing, but again, quite small. But we are going to work and look at those 3 crops. So we began to look at how these resources were being utilized across Europe. And we have found over 32 companies across Europe manufacturing bio-based construction materials and products from all 3 materials, and also about 11 or 12 modular system manufacturers. So that's quite a lot of activity and quite positive. So we're seeing everything from boards, bats and quilts to people extracting key bio-based materials like cellulose or lignin from these resources and using them in other applications like cellulose insulation or cellulose foaming, or as an additive in other materials like concrete or in tarmac. We're also seeing, the hempcretes and the miscretes and the development of bio-based blocks. So quite a diversity of work being done there, and that's really encouraging. And as I said, parallel with that, we're also seeing the application of these materials in modular systems, which is really helping to mainstream the materials and enter larger scale construction markets and a whole diversity of building typologies. And again, straw, miscanthus and hemp are being used in that. Interestingly, within the product range, the most significant product across Europe are hemp-based materials in terms of number of manufacturers, but in terms of modular manufacturers, they will be dominated by straw, which is interesting. And a key aspect for us to explore and develop is trying to facilitate and initiate supply chain. So we've been reaching out and talking to different manufacturers across Europe about their supply chain and looking at the agricultural aspects and the processing, very particular processing requirements depending on the resource. And then the manufacturing, depending on whether they're developing a low-tech solution or like a straw bale solution, or whether they're developing a more advanced product like cellulose foaming. There's a whole diversity of manufacturing issues. And then, of course, they all need to be integrated within a very sophisticated construction sector that's got very high performance and regulatory requirements. So it's no easy task to mainstream these materials, but we are seeing it happening across Europe. This is an example of a supply chain map from our colleagues Building Balance. So they're mapping on the left soil typologies that may suit particular crops, and then engaging with the farming and processing sector about how they could be utilized, and then mapping out what type of components they could manufacture from those, and wall, roof and floor elements, and what area of construction they may go into. This is a particular straw bale modular system that was developed in the Netherlands, with demand being generated often by the housing sector, housing associations, and contracts being drawn up and for supply over a 3 to 5 year period. So that's the type of strategic supply chain development that's happening in the Netherlands. Interestingly, we're seeing a range of EU projects in this area, focusing on bio-based materials, but also interestingly, a number of European states are developing their own regional or national bio-based support funds. So we see one there in Italy developing the hemp fiber sector, and a Dutch one developing circular bio-based materials, and a massive financial investment being made there. So where we're at with the project, well, we've been focusing on researching the agricultural sector and the construction sector in terms of the changes that are happening. We've done quite a detailed inventory of these 32 companies across Europe, what they're making, what they're producing, what their resource is, the type of performances their products are getting, and how they're being utilized, and that would include the modular application. We've developed a very strong stakeholder advisory group and a stakeholder network now in Ireland, and we've ran a number of online seminars. We're going forward, we're continuing to engage with those stakeholders, and we're in the process of establishing a supply chain working group who will be involved in roundtable workshops starting in September, to actually begin to map out how supply chains may develop regionally in Ireland. Parallel with that, we're beginning to design and develop potential mock-up solutions, and we hope next year to build and test those. And by year 3, we would be really excited if we saw a number of emerging supply chains happening across Ireland. So we are talking to straw grower groups, miscanthus farmers, and 2 commercial entities that are very interested in hemp supply chains. These are some of the key dates we've been working to. We've our next seminar coming up on the 19th of June, which is focused on social housing and local authorities and how they can, through green public procurement, promote bio-based construction materials, and look at a UK example actually, and also a Dutch example of social housing utilizing significant bio-based resources. That's our seminar for June. So that's an overview of the project. Very happy to answer questions. We're at an early stage. We're about 8 months into the project, but really grateful to have the opportunity to meet you and to speak today. And hopefully we can get involved and maybe learn from what's happening in Scotland as well.
Thank you, Patrick. That's been really, really engaging and informative. I think what's exciting about your particular project is that it's targeting retrofit at scale. It's looking at these aspects of social housing and how the local authorities can actually see the benefit of the construction and agriculture sector working together. And it is very pertinent for Scottish example, for example, as well. There's a question in the chat that I thought I would just ask right now. If the link to this seminar for June can be, the invitation can be sent to the attendees today. Is that
Yes.
open to everybody?
Absolutely, it's a public seminar.
Okay, that's perfect.
Yep.
I'll pop it.
We'll forward on the link and the registration for it.
Wonderful, thank you so much. Perfect, thank you, Patrick. Before we move on to other questions, we'll jump on to Elliot, who can tell us a little bit about himself and his background and his very special project and how that developed into a lifelong adventure, let's see. Over to you, Elliot.
Hello. Is that my first picture up? There it is. My name's Elliot. I'm trained as an architect, but got into architecture via listed buildings. Set up my own practice after working in various other practices about 10 years ago, and carried on working with listed buildings, including some stately homes and some old farmers' cottages and old military installations. So a wide range of building types, materials, and that sort of led me naturally into connecting those back with a sort of interest born from school of sustainability, etc., and it being presented all these sort of solutions given by the old buildings about how to get rid of damp or how to sort out this complication for them. And so when the opportunity came to build our own house, we were then living in London, myself and my wife, 2 children, and my wife's practice. She's an artist, becoming more and more needing more and more space. We decided to sort of decamp and move back to where she was from in Scotland. So this is the farm. We bought the farm buildings, not the farm, based just outside of Edinburgh. You can see Edinburgh on the other side of the Forth there. And it was in a terrible state. Next slide will show you that. Do you want to do the next slide, Magdalena? This is pretty much what all those buildings look like inside. There was two large barns, and this is the old stable. There was a new machinery shed that had been sort of shoved in, crowbarred into the existing buildings, and it was. I don't know quite why we did it, but the intention from day one was to restore or to give a new lease of life to all these sort of beautiful stone buildings, and do that obviously with natural materials, because that's where my head had arrived at after all these other buildings I'd seen and worked with. So it was the only option, and we looked at lots of different solutions for that. But obviously, because of these walls are like most of the walls on site are 500 to 600 thick stone, and they're a mixture of quite impervious basalt and quite pervious sandstone. We knew we'd be sort of managing moisture in these walls quite significantly, and we settled upon using in this first building here that you're seeing. This is the stable. This is the first one we would tackle. We would use a cast hemp on the inside, alongside a wooden roof grown in the UK, Douglas fir. We put on top of that more hemp, and came with lots of different solutions. I'll show you the pictures of that and how that all went together. But it was, it took us a long time to get to starting to get our head around how that was all going to work, how you talk with the engineer about the weights of things, and then you're talking about the detailing and the roof detailing, and putting all these pieces together, which are all slightly different, and no one's totally comfortable, knows the way around that particular detail 100%. So there was a lot of conversation that needs to get us to even a starting point. Next picture, please, Magdalena. That's that same room now. So we have spent a lot of time and a lot of energy to get it there. My father-in-law and myself actually dug out all of that mess you saw inside there, including the original roof and all the tiles that were on it. The farmer had sort of left lots of old machinery in there, and some very odd looking chemicals that we had to get taken away by someone in a nice suit. So it was a difficult process. Moreover, we made a couple of mistakes, and anyone who was at Cedar conference would have I used it as an opportunity to air my worries about how many mistakes I'd made during this process. But I think what the difficulty that I didn't anticipate was, for instance, we got this roof. Trying to find this roof was the timber for this roof at C24. Took some time, took some planning. By the time we got it up and running, we were already well through the year, and we were having it made up down in a in a factory so we could get it all perfect and then bring it to site. But that became a pressure rather than a help. You know, we thought, oh, brilliant, off-site construction, bring it on, put it on. But complications on site and certain difficulties meant that this was ready and waiting. And it put the pressure on me to think, I need to get it on. I can't have them holding it in their workshop, clogging up their workshop more and more. We brought it to site, and at the expense of putting in drainage around the building, the French drain around the foundations, we had to underpin the building. We put the scaffolding up, and that meant that we severely underestimated the amount of water that was going to come through the ground, to a point that on Boxing Day of 2022, I walked in to find 2 inches of water on the floor of the house, and we cast the hemp about 3 weeks before. And that meant that the hemp did exactly what it's supposed to do, and it took on all the moisture, not just the moisture that we were trying to protect it at the bottom, but the whole room was so wet from this influx of water. And it took to about May last year to actually stabilize that building. So it was my first realization that, you know, you can make quite little, well, what you think are quite little decisions about timings and stuff, and cost yourself so much trouble, because these materials they're living, and that's what you want them to be. You want them to take on moisture, let go of moisture. You want them to be reactive and be attending to the chaos of the world. But if you add too much chaos in, it was like we did, then I've caused myself quite significant difficulties. Next picture, Magdalena, please. The next picture, I think, is that's pretty much the sort of few days after the first casting. So on the left, you can see the cast hempcrete up against the internal walls. The gable is in hemp as well, but the wall with the door in it is actually diathanite. This was done to achieve just a depth of in this room, to allow us to get a certain amount of cupboarding and kitchen into that room. It was the hempcrete is about 160 wide. We had that dynamically modelled so we could work out the best thickness of hempcrete to avoid condensations, etc., against the stone. So letting enough warmth through the wall, in fact, to make sure that we weren't freezing out this wall that would periodically become wet and dry and wet and dry. Next photo, thanks. This is the roof construction. I was saying there was a mix of different types of hemp. So in the verges and where there were changes in levels, we were using bits of cast, but for weight reasons that we didn't want to up the size of the timber trusses inside, we balanced that by using hemp block, which was a lighter solution, and we used that at lesser depth, and then packed in with sheep's wool, funny enough, rather than hemp bat, sheep's wool to sort of pack in and make everything a little bit more airtight, before wrapping that in papers and covering in zinc. So again, there's a sort of mix of materials and a mix of solutions to work it with this old listed, no, but no, it's not listed, old building and the challenges that provided. Next picture. This is just to tell you about that weather and how these materials, you know, as best as we tried to build this all in the summer, the world just didn't work like that for us. And maybe, yes, I should have stopped and had that guts to say, let's start in the spring, but I didn't. And I think it's what, you know, we then tried to solve that problem by putting a temporary roof on, but the temporary roof leaked. That whole way of construction is sort of, you need to start at the bottom and come to the top, and that takes time, and time against, in the dry weather, it's a very difficult thing to achieve. So still haven't quite got my head around that as we move on onto other buildings on the site, about how we will achieve that and how we avoid these sort of temporal and ways of saving the materials you're using. Next photo. I just wanted to give a little brief bit, which Magdalena, I don't know you've seen, since this was one of the original buildings on site, but it was twice the length of this and used in a different way. And we managed to take it down, take the steel down and have it polished up at 4 minutes down the road, and then taken 10 miles to another village where there's a blacksmith who checked it and had it all welded with new lugs so we could put it back together in a different shape, and we brought it back to site. So it's done about 15 miles round trip and come back to site and been installed as a new building and under a residential category. So I think our engineers think it's the first building in the UK that's steel building that's been taken down and refitted and rebuilt as a new building, not an agricultural shed. Now it's a residential, part of a residential site. So I'm pretty proud of that, but it took a few jumps of faith and to try and achieve that. Next photo. That building, this is Stevie, our site agent, who's been working with us over a year. That's him installing ISO hemp bat on that roof. So basically we've got a timber kit that's gone in between that steel frame. Next photo. And inside we're using glaze pour on top of the original slab. The original slab is contoured, so we've managed to get a minimum of sort of 200 mil cover, which gets us just inside our I think it's 220 actually. It gets us just inside our need for our building regs. We'll cast a screed over the top of this, but we were quite happy to mean that we didn't need to sort of dig down. And obviously the height, we've lost a bit of height in this building, but it's still achievable as the building we need it, the purpose we need for this building. Next photo, Magdalena. And then using sort of locally sourced woods for the cladding and such, found a great local supplier who all his stock comes from within 50 miles. This time it was a lot easier. Now I know the area and I moved up here to find wood, unlike trying to source the Douglas fir the first time round. So there's something about just contacts and knowing your area, which is really important. Next photo. Because on that conversation about some larch, we ended moving up to looking at could we do the finishings in local blown down timber. So this is all sycamore. Rather than having to use sort of, dressed red or something from your local timber merchant. There was slightly elevated cost in this, but nowhere near as significant as, or it would be equal to choosing a poplar from Canada or something like that. So more expensive than your dressed red, but a product that's a similar quality from brought across the ocean. And then that's allowed us to dress out around the building. So this is one of another guys working out a detail problem when it was -5 during the winter, where we had to put the windows on the outside skin, and where the hempcrete and diathonite were their thinnest, we were getting damp forming on those. And obviously the building was still quite wet from painting and plastering and such. But we've just taken an opportunity to pad these out, and we've used cork behind there and to kind of keep some of the wet, moist air away from that area by paneling out around them using this sycamore as well. Next photo. And that's Dylan, our painter, that's going around slowly behind everyone, making it all look great. But we've been using Kime paints for the walls, and yeah, we're just sort of getting everything now tidied in and sorted out. But it's been it's nice to see it starting to look like a house after too many years and sleepless nights. But there you go. There's quite a confused run through our project.
Perfect. Thank you so much, Elliot. Right. Okay. Well, let's open up the floor then. If anybody would like to ask any questions, please raise your hand and we'll let you speak. If you want to just put it in the chat, I'll read it out. I see there was one question that Cypren already answered, but I wondered if you would like to elaborate on that in the 8 minutes that you have. Oh, sorry, you're on mute.
Can you hear me now? Can you hear me now?
Perfect. Yes.
Yes.
Thank
Yes.
you.
Good. Yes. I just put the answer in relation to that particular question. I think the big question that Sam was asking was in relation to fire. There are a number of misconceptions regarding fire-based materials, in particular straw. So with straw bales, if you're going to build your building, if you're going to construct your building with straw bales, you've got to bear in mind it's the density with which those bales are formed. Yes, so you haven't got the oxygen to breathe through and to enable all kinds of mayhem around you. It was interesting because moving forwards, right, as to where we want to go in the industry, specifically around constructing quicker, straw panels enables you to do that. And Barbara Jones yesterday on a talk was talking about and referring to straw panels, and she informed the audience that working with standard panels, 22mm rendered with clay, 2 hours is the kind of time we're talking around for, you know, a fine demonstration. So I hope that answers the questions.
Perfect. Thank you. We don't have any questions in the chat just yet, so I was going to ask something that we have been sort of touching on in what Elliot also described. So in terms of resilience, in response to heavy rain or flooding, how do these materials, these natural materials, respond? Who would like to take that first?
Is that a question for Elliot?
I think they respond exactly how you want them to. Like, we can't have everything. We can't have the impervious plastic that would mean that you don't have that problem and have something that's breathed. The fact is it needed me to be cleverer and think better about the potential knock-ons. So it's not the material, it's the planning of its installation. So if I'm to, you know, that's why I came to the conversation back in October, is to tell everyone that I messed up, because it's really important that people are thinking about how they do this, because the materials are great, they do everything we want them to, but if you allow them to get so wet they can't dry out, it's, you know, that's not the materials problem. If you install it with some with consideration for those things, it works perfectly. And to be fair, it has worked perfectly. It took me to May for it to dry out, but it dried out in the end, and it's been plastered and it's working perfectly. It's not a fatal error. Whereas if you had water trapped between 3 layers of plastic and some plasterboard, it would be a pretty bad situation for you. If I made that same mistake using non-natural materials, maybe I'd be in a worse position. But yeah, there we go.
Yeah, and just to add to that, specifically around straw, a question that is often posed by people who are who know very little about how to construct with straw. It's really, it comes down to the transport of that particular material. So you've acquired it from the farmer, and you've then gone and put it in your field to begin work on. Now, if you don't cover it up specifically with an appropriate amount of tarpaulin, then you're going to be in trouble, because what will happen, you'll have mouldy bales, and you don't want to be building your home with mouldy bales, because that then opens up the opportunity for pests and vermin. So and I suppose I've just conflated that with another misconception that people have around mice and rats, etc. They don't, and they've got no interest in straw in that regard. But if you leave it open to them, then hey, they're going to come in and look around.
Thank you. Patrick, would you like to add something to it in terms of testing and what you have to consider specifically for your project? Oh, sorry, you're on mute as well.
In relation to moisture, obviously flood risk is a very serious risk for any building material. At the very least, these materials have the ability to dry out. It's really only sustained moisture where there's high relative humidity in the 80% range for significant periods of time that will lead to rot. So these materials can absorb moisture. They're hygroscopic, so moisture doesn't just pass through, it is absorbed within them and they re-release. So they regulate moisture. They do that naturally very well. So it's really about understanding the materials. They can be designed for high performance and long-term performance if they're moisture protected, both from particularly driving rain and wind, and if they're designed so that vapor passing through is being released, and especially it's not condensing, that it turns to water. I mean, water is different to vapor in terms of its impact. So we know we can design these materials to function well in constructions if we do that smartly. So it's about really understanding moisture control, water ingress, and vapor transmission is all really important to understand. And if that's understood, we then use these materials, we optimize them, because they're no longer creating a risk for moisture, they're actually helping regulate moisture. And that's one of the real health benefits of these materials. But certainly long-term flooding or regular flooding will be a major problem for any construction material, I think. But moisture regulation in terms of wall, roof and floor assemblies is completely technically achievable if one understands the first principles of moisture control. And of course, there is important testing to be done there. We're seeing increasing, I mean, the materials I know best are hemp and straw. The amount of scientific literature researching into these materials is phenomenal. There are dozens and dozens of papers on thermal conductivity of straw, for example, on its hygroscopicity. So all that research is very helpful, because it's allowing us then to model like moisture transfer or energy modeling. We have the specific heat capacities, we have the densities. So that really helps with modeling and simulating of design solutions. So that's very helpful. And then particular manufacturers are involved across Europe in very rigorous testing to meet national or European ETAs. There is a European EAD now for straw bale construction and for straw blow-in insulation. And so numerous companies are now testing to show compliance with that EAD, and energy assessment descriptor, or environmental performance descriptors. So there's an increasing range of data, and there's increasing evidence of individual manufacturers meeting and getting ETAs and getting certified, and building multi-stories as well. So it's quite exciting what's happening. We're seeing multi-story straw buildings, multi-story hemp buildings. I think the challenge is professionals like CIAT members actually probably need to catch up with where the industry is actually at, where the technical capacity is, and understand how to design and specify these materials well, and avoid technical problems. So I think there's definitely an education and training need within the profession to understand the dynamics of the materials.
Perfect, thank you. I am very aware of time, so would our speakers like to offer any final remarks before we break off? Cypren?
Yeah, there was one. Can you hear me okay? Because
Yep.
I lost my mic for some peculiar reason. Building costs. I just noted a chat in the chat. There was a question regarding building costs. Again, it's another misconception that it's more expensive. They're no more higher than similar thermally efficient buildings. In some cases, they're lower. And contractors are able to adapt to this modular system, specifically straw panels, because carpenters in particular, they can transition their skills. Yes, I know that there is a specific site that Agri-crop currently working on. It is the tallest straw panel building in the world. And the cost comparison for that is that they've said standard costs for 2,800 to 3,000 euros per meter squared. That would be a standard typical conventional cost, but for this particular site, they're saying 2,300 euros per meter squared. So that in itself should speak volumes. I'm not sure where they are presently at this moment in time, but I know that work is underway. So you've heard it here first, and I'm open to say that because they've already publicised that. They've spoken about it several times publicly. But yeah, the misconceptions regarding bio-based materials, we really need to get rid of that if we're going to move forward.
Thank you. Elliot?
On that costing, one of the reasons we will use hemp in the further studio building is that we need moisture control, and it should avoid us needing to put any electrical air handling kit in there. So when you start, it's not just doing your insulation, it's doing other things as well, and it's comparing apples for apples, and then they're not. So that's always to think about. I think there's as with the whole of this world, you have to think about the whole system of things working together and what your overall costs and what your overall solutions and advantages and such are. So that'd be my final parting shot.
Perfect, thank you. And Patrick?
My final comment would be a call out to colleagues to step forward and begin to specify and design these materials, maybe project by project. Each project learns something new, innovate, iterate, and apply something new, and build up a competency. We really need the design professionals now to start advocating and implementing these technologies. And this cost question will begin to get resolved as the scale of demand increases. But we do need to get it right. We really need to avoid large-scale technical failures and things like that. So we really need people to engage competently and technically.
Perfect. What a better way to finish. Thank you so much for being here with us today and for your insights. I think everybody enjoyed it.